Hello students, welcome to the topic differentiability. In this topic, you studied that how to check differentiability of the function and how to find derivatives of standard functions using the rules, composite functions, implicit functions, inverse trigonometric functions, and using substitution method, parametric functions, logarithmic functions, and logarithmic technique, and double derivative of the y function, and two important theorems on derivative. In this video, I'm going to solve more number of examples on derivative. Now see the first question. Find the derivative of sin x with respect to cos x. Students, so far whatever we are used to find, that is dy by dx, it is nothing but y function with respect to x variable. Now this question is different. We have to find out derivative of sin x function with respect to this function. Understood? That means derivative of sin x function not with respect to x variable, with respect to this function. Okay, so how to find a derivative? It is very simple. So see the solution. First denote the first function, that is a sin x, as a y function. Let y is equal to sin x. And the second function, that is with respect to what we have to find out now, that is as a z function. Z is equal to cos x. The question asked is this function with respect to this function means dy upon dz. Understood? Because z is a cos x function. So you have to find out here the derivative of y function with respect to z function, that is denoted as dy upon dz. I hope you understood. So what we have to find out here, dy upon dz. So this is called derivative of the function with respect to another function. Now it is very simple to find dy by dz. Y is a function of x, z is also function of x. Find out these two functions derivative and divide it, you will get dy upon dz. Therefore, find derivatives of y function and z function with respect to x variable. So differentiate with respect to x. Dy by dx is equal to sin x. It is very simple function. Its derivative is cos x. And z is also simple function. What is a z function derivative? That is dz by dx. It is minus sin x. So now I am finding dy upon dz. The meaning of dy upon dz is nothing but y function, that is sin x function, with respect to z function, that is cos x, equal to dy upon dx divided by dz upon dx. So that is equal to cos x, because dy upon dx function is cos x and dz upon dx is minus sin x. So further writing, dy by dz is given by minus as it is, and cos x divided by sin x, it is nothing but cot x. So this is the way of finding derivative of one function with respect to another function, that is dy by dz. Now see the next question. Similar type example. Find the derivative of sin square x with respect to e raised to cos x. Now see the solution. First take the sin square x as y. Let y is equal to sin square x function and z is equal to e raised to cos x. We have to find out dy upon dz. So therefore differentiate these two functions y and z with respect to x. Differentiate with respect to x. So dy by dx, let's write. So sine square x function. So this function is now composite form, that is function square. So the derivative is given by 2 function, that is sine x. After that sine x function derivative cos x. So using that function square, 2 times function and function derivative. Here sine x is function. And dz by dx is given by, it is a composite of exponential e raised to f of x. So the derivative is given by same function e raised to cos x. After that function derivative, that is minus sin x. So in the next line, dy by dx write as it is, and dz by dx minus sin x into e raised to cos x. So now I am finding dy by dz. So it is equal to dy by dx divided by dz by dx. So here dy by dx is 2 sin x into cos x divided by, and dz by dx is minus sin x into e raised to cos x. So in this sin x is cancelled. So you will get a dy by dz is equal to minus 2 cos x divided by e raised to cos x. And this is a dy by dz answer. That is derivative of sine square x function with respect to e raised to cos x function. Now see the next question. If cos y is equal to x into cos of a plus y with cos a not equal to 1, then prove that dy by dx is equal to cos square of a plus y divided by sine a. This example is different. It is not function with respect to another function. It is a different examples. So here you have to prove that dy by dx function is cos square of a plus y divided by sine a. Now see the solution. The solution is very interesting and very simple also. We are proving this example in different way. First you take given function, that is cos y is equal to x into cos of a plus y. Here I am not differentiating directly this function. Okay, here it is a product of two function and here it is a single function with y variable, but we can differentiate, but to get this proof I am not going to differentiate this function directly. Now in this answer you can see that it is a free from x variable. So therefore what I will do to eliminate this x answer in the derivative function, I transfer this cos function left side. Okay, therefore cos y divided by cos of a plus y is equal to x. Now here we got a function x in terms of y variable. Understood? Now what we got, x is equal to cos y divided by cos of a plus y, means x is a function and this function variable is y variable. So in previous examples we are differentiating a y function with respect to x. Here x is a function now, y variable function. Okay, so therefore differentiate with respect to y variable. That means now if you differentiate y variable, don't multiply dy by dx, because with respect to that variable only we are differentiating, and it is a division form, that is a quotient form. So to write the derivative you have to follow quotient rule. So according to quotient rule, denominator function as it is, that is cos of a plus y, and derivative of cos y, it is minus sine y, and don't multiply here dy by dx because with respect to y variable only we are differentiating. Okay, minus cos y as it is. Now derivative of cos of a plus y, it is composite, minus sine of a plus y. After that a plus y derivative, a derivative is 0 and y derivative is 1. So therefore no need of writing here 1. That is cos of a plus y derivative is minus sine a plus y whole divided by square of the denominator, that is cos of a plus y whole square, is equal to, so x function derivative is dx upon dy. I hope you got it, how to differentiate this function with respect to y. Next, this minus I return first, cos of a plus y sin y, and this is plus because minus into minus is plus, cos y sin of a plus y whole divided by cos square a plus y is equal to dx upon dy. So let me keep this one as it is. We have this equation. Okay, now see the numerator expression. It is of the form sin a cos b minus sin b cos a. Now in this answer, we have the same expression in the numerator. See here, this if I denote this as a angle and this as a b angle. So y means b, a plus y means a. See, it become sin a cos b, that is first expression, minus this minus sin b cos a. So that means this numerator is nothing but this expression. So therefore this can be written as sine of a minus b. Okay, it is called as compound angle formula. So therefore numerator now it is written as sine of a minus b, that is a angle, it is a plus y, minus, and b is y angle, that is y. So numerator, this entire term, it is written as sine of a plus y minus y divided by cos square of a plus y as it is, equal to dx upon dy. Now further simplifying, you will get y and y get cancelled. Sin a divided by cos square a plus y is equal to dx upon dy. Now taking reciprocal, you will get the dy upon dx function. So taking reciprocal, we get cos square a plus y divided by sin a is equal to dy upon dx. And in the question, this is only asked to prove that dy by dx is equal to cos square a plus y divided by sin a. So this is the proof of the given example. I hope you understood different examples on derivative. Thank you, students.